Hello and welcome. It's your main math man, Mr. Lyons here with the top of page 112. Right, you just identified lines of best fit, seeing if they minimize the distance from the other points, making sure that the line has the same amount of points above and below. And right now we're going to construct a scatter plot, and we're going to draw a scatter plot, and we're going to write an equation of the line of best fit. And we're going to talk about that in a second, right? So right now we're talking about a radio and the number of listeners when it reduces the time used for advertising. Now, you could think about this. I know y'all use TikTok a lot, right? Would you want to use TikTok a lot if there was a whole bunch of advertisements on there? Like every other minute, it was advertisement, right? So if you reduce the advertisements, maybe more people would listen. Possibly. We'll take a look if that works with radio, right? So we're going to draw a scatter plot here. But the first thing is, it says write an equation for a line. A linear equation. How do we write lines again? Linear equation, write a line. What does that look like again? Y equals, what is that again? Mx plus b. You already know the vibe. Slope-intercept form. You need the slope, you need the y-intercept, right? Now, I want to take a look here. I use the same strategy I used in my previous lesson for how to scale when you're dealing with x and y, right? This is my x in time, my y number of listeners. So for my x, I counted 10 spaces, and my highest number here was 26. And so I just divided. 26 divided by 10 is 2.6. Rounds out to about 3. So I counted 3. Do the same strategy. Pause the video. Do the same strategy. What's the highest number here? How many spaces do you have? How many units do you have to count from? Divide that. That's 420 divided by 10. It's about 42. Rounded that to 40, so I counted 40 for my number of listeners. Go ahead and pause the video if you need to. Make sure your graph looks like mine. Okay. And now what we're going to do is we're just going to plot these points here. Create our scatter plot. That's part one. Draw our scatter plot here. So I have 26, 240. So 26, close to 27, 240. Check. 21, 180. 21, 180, just in between 200 and 160, right? Counted by 40 is 180, 200, right? And then we have 18, 280, 18, 280. Look at that lattice point right there. 16, 300, 16. It's closer to 15. 300, it's right in between 280 and 320. Then we have 14, 410, 14, closer to 15. 410, just about 400 there. And then we have 12, 420, 12, 420. Beautiful. Now that I have my points down, I can create my line of best fit. Remember, you want to minimize the distance between its points, and you want to try to make sure you have the same amount of points above and below. I want you to do this on your own. I'm going to put my camera down so I can use my ruler. We want to do this real time. And do it real time, right? And we're going to draw a line of best fit, try to have the same amount of points above and below, and minimize the distance there. Go ahead and make your line of best fit as best as you can. Not sure about you, but I kind of feel like I have a little bit of an outlier, just a little bit here. All right, 3, 2, 1. Take a look at my graph here, right? My line of best fit was actually able to go through 2 of the points, and I have 1, 2 above, 1, 2 below, 2 points going through. Now, this is kind of a little bit of what's that word? It starts with an O, an outlier here. Just a little bit of an outlier, a little bit. It's not super far off, but notice how this one's far off. That doesn't really matter too much in a scatter plot. As long as it's minimized for most of the points, you'll be all right, okay? So make sure your graph looks like mine before we continue. Now, we're going to write an equation here, but Mr. Lyons, what points do you use? How do you create an equation here? Well, it's called slope-intercept form for a reason. You want the slope, you want the y-intercept. The easiest thing to calculate is usually first the slope. How do you calculate slope? Well, slope I know is the change in y over the change in x. So how do you find the change in y over the change in x? You have to first organize your points. Now, what 2 points do you think I should use here? Yeah, that's right. I'm going to use the points that are closest to my line of fit, which is going to be, what was that? 12, 420. And this point right here is 18, 280. right? 420 to 280 is what? What's going to be that change right there? I'm almost positive that that's going to be what? 420 minus 280 is 140. Excuse me. How you gonna let me do that? It's negative 140, right? Decreasing here. And this is going to be plus 6. And now you're just going to find out what that information is. If you need to get your calculator, I know I put that at the beginning. You should get your calculator, okay? So that's going to be 140, negative 140, over positive 6. When you go ahead and divide that, what do you get? What do you get? You should get about negative 23.3 repeating, right? And you can go ahead and round that if you want to. Feel free to go ahead and round that if you want to. That's completely fine. Absolutely fine. Because we're approximating here. So I can round that to approximately negative 20. Okay, it's about negative 20 right there. And you can use that now that you have your slope. Now that you know your slope is approximately negative 20, you can go ahead and find your y-intercept now. How can you do that? Because now that you have your slope, all you need to do is just pick 2 points. Just pick 2 points and plug them in and see what you get, right? Let's take a look. Let's calculate our y-intercept now. Yeah, I know this is ringing bells for some of y'all. Y equals mx plus b is our original equation. Now I'm going to I just used 12 and 420. Let's use 14 and 410, right? My y is going to be 410. My slope is negative 20. That's the slope that I'm using. My x is going to be, if my y is 410, my x is going to be 14 plus b. Oh. You should be able to do this on your own. Pause the video and do this on your own. I know you can. I know 2 times 14 is 27. Add that 0 there, and that's going to be, 2 times 14 is 28. Add that 0 there, and this should be negative 280 plus b. Add 280 on both sides. This should give me close to 700. This is just about 700, 690, right? This is what my b is going to be equal to. Beautiful looking work here. All right, it should be just about that, just about what we got here, right? And so now that we have our slope, now that we have our y-intercept, you are prepared to write your equation down. Y equals negative 20x plus 690. And that kind of makes sense. Because we have a negative slope here, a negative relationship. But if you continue to go up, you should get to about 600 right around that mark, right? If you continue your line over there. Because we're starting at about 700 listeners, approximately. But the more advertisements you put up, you're going to lose about 20 listeners per minute. So the more advertisements you put up, you're going to lose just about that much, right? And one of the things you can do to check this is you can just plug in and substitute another x and y value to see if it sort of makes sense, right? That's all you need to do. So actually, let's try that right now. Y equals negative 20x plus 690. Let's go ahead and use, 16,300, right? 16, 300. We should get about something that makes some sort of logical sense here, right? Y is 300 equals negative 20 times 16 plus 690. This should give us a close to a true statement here. 300 equals, what is 16 times 2? 32, negative 320 plus 690, right? What is 690 minus 320? You should get 370. Now, it's kind of in the ballpark, even though it's not absolute. Remember, this is kind of in the ballpark here, and that makes sense because when we rounded, we sort of gotten smaller, our slope got smaller. And so when we rounded, that's completely fine. So this is not absolute. Remember, this is a scatter plot. Things are going to be a little scattered, but as long as it's somewhere close. Now, if we got 300 equals, 1,000, that would mean something's off. But this makes quite a bit of sense for our line of best fit for this particular situation, right? Don't forget what line of best fit means. keeping the same amount of points below and above, making sure you're minimizing the points here. And on top of that, you know how to calculate slope, right? Choose two lines closest to your line of best fit. You know how to calculate your y-intercept once you have the slope, and you can construct the line once you construct your scatter plot, all right? Thank you for watching. Thank you for listening. Constructing scatter plots, making lines of best fit and equations, and I'll check you next time.